Okay, next we will calculate the width of fringes, of the width of dark spots and bright spots. As I already mentioned before, that if we look at the screen after interference, then the screen consists of bright spot, dark spot, bright spot, dark spot, maxima, minima, maxima, minima. Maxima tell us bright spot, minima tell us dark spot. Bright spot or maxima comes from the constructive interference, and dark minima comes from destructive interference. Now we have to calculate the width from this point to this point, the width of dark bright spot as well as the width of dark spot. Now here I will draw my screen figure again. Let's suppose this is the screen. Now on this screen we have, let's suppose this is the central bright spot, central bright spot. After bright we have a dark. Let's suppose this is the first dark. Let's suppose this is the first bright spot. Let's suppose this is the second dark spot. Let's suppose this is the second bright spot, and so on. So this is the central bright spot, this is the first dark spot, this is the first bright spot, this is the second dark spot, this is the second bright spot. So if I come to this figure again, then this is the maxima, central maxima. So this is the central bright, this is the first bright, this is the second bright, this is the third bright. Here after central bright we have first minima, our first dark spot, then we have first bright spot, then we have second dark spot, then we have second bright spot. So if we look at here, this corresponds to this one, this corresponds to this one. We'll keep it like this. This corresponds to the central bright, this is the first dark, this is the first bright, this is the second dark, this is the second bright. So the bright and dark spot, they are consecutively after each other. Now we have to calculate the width of, let's suppose, our fringe, width of bright fringe, width of bright fringe. Now the width of bright fringe, the width of bright fringe, this is the width of bright fringe. Let's suppose it's from here to here. The width of bright fringe is basically the distance between two consecutive dark fringes or dark spot. So I can say that the width of bright spot will be equal to, if this is my y, this is the central point 0, then it is the distance between two consecutive dark spot. So the first dark spot is this one and the second dark spot is this one. So it is the distance, this distance. This tells us about the width of bright spot. So it is, this distance is y 1d, the distance of first dark spot, or the position of first dark spot, and this distance is, this is the distance of second dark spot. So this will be equal to this minus this, so it's y2d minus y1d. Now we already calculate YD. Which is 2m plus 1 lambda d over 2d. So y1d, if I put m is equal to 1, it will give us the position of first dark spot, so which is 3 lambda d divided by 2d. And this is for m is equal to 1. Y2d, which is equal to, if I put 2, m is equal to 2, so this will be 5 lambda d divided by 2d. This is for m is equal to 2. Now using these values here, we get the width of bright spot, which is 5 lambda d divided by 2d minus, this is small d, sorry, this is small d, minus 3 lambda d divided by 2d. If I subtract this from this one, we get lambda d over d. This is the width of bright spot. Similarly, with the width of dark fringe, again I will plot my screen figure here. This is the central bright, this is the first dark, this is the first bright, this is the second dark, this is the second bright spot. So the width of dark space, this one, WD, will be equal to the difference or the distance between two consecutive bright spots. So here I will consider this is to be y2b minus y1b. This is the position of second bright spot minus position of first bright spot. Now we already calculate the distance of bright spot, which is m lambda d over d. So y2b will be equal to 2 lambda d over d for m is equal to 2, and y1b is equal to lambda d over d for m is equal to 1. If I put these two values here, we get the width of dark spot, which is 2 lambda d over d minus lambda d over d, which is lambda d over d, or the width of dark spot is lambda d over d. If I look at this equation, and also we have this equation, we see that the width of bright spot is equal to the width of dark spot. So by this way we can calculate the width of bright spot and dark spot. So the width of bright spot and dark spot depends only on this wavelength lambda, and also the separation between the two screen, and also the separation between the slit. If the separation between the slit is large, the width will be small. If the separation is small, the width will be large. If the distance between the screen and the slit is large, width will be large. If it is small, width will be large. And similarly, it depends on the wavelength. But we are using monochromatic wavelength. By monochromatic means we have the single wavelength. So it's the width basically depends on the geometry of the apparatus. It depends on the width of the, it depends on the distance between the screen and the slit, and also it depends on the distance between the two slits. So this is all about width of bright and dark spot. So next we will discuss about intensity and double slit experiment. So which I will do, I think it's better to do in the next video. I will do it a little bit in this video. Next we have intensity, and double slit experiment. So by intensity I means intensity can be defined as power per unit area is called intensity. Now we already discussed that. First I will plot my figure again. Suppose these are the two slits. Here we have the screen. Suppose array, this is slit S2 and this is slit S1. Suppose a ray coming from slit S1 and reach to point P, and another ray coming from slit S2 and reach to point P. I call this is, let's say I call it, this is x1 and this is x1, sorry, and this is x2. This is R1 R2, it's okay. Here I will use the notation is x1 or x2. Now we have the path difference. The path difference is this one. This is the path difference, and this is the separation between the slit. This is separation between the slit, and this is the separation between the two screen. One screen is tell us about the bright and dark spot, and in the other screen we have the slit, and we have this light waves coming here. So here at this point P we have either constructive interference or destructive interference, which depends upon this path difference. So due to destructive interference we have dark spot on the screen, and due to constructive interference we have bright spot on the screen. Now for constructive interference, the path difference delta L, this path difference I call it, let's suppose delta L. Delta L should be 0 integral multiple of wavelength m lambda, so it should be 0, lambda, lambda, and so on. And similarly for this is for constructive interference. And for destructive interference, this delta L, this path difference, this is path difference. This path difference should be an odd multiple of wavelength, means 2m plus 1 lambda divided by 2. So delta L should be lambda divided by 2, 3 lambda divided by 2, and we have 5 lambda divided by 2, and so on. So we consider a light ray R1 passing through slit S1 and light ray R2 or X2 passing through slit S2. They coming from this slit S1 and S2, and they combine at point P on the screen. Now if the path difference, this delta L between these two rays X1 and X2 is 0, lambda, 2 lambda, or 3 lambda, 4 lambda, then what will happen? We have a bright fringe, a bright spot at this point P. And if this path difference delta L between this ray X1 and X2 is lambda by 2, 3 lambda by 2, 5 lambda by 2. Then this point P, we have a dark spot because the two rays will interfere constructively, so they cancel the effect of each other and we have a dark spot here. Now we know that sunlight, light is an electromagnetic wave, and it consists of both electric and magnetic field. I already mentioned before. This is electric field and this is magnetic field, and this is the direction of propagation of this electromagnetic wave. Now the effect of magnetic field is negligible at point P. So we have only the electric field have effect at point P. So it means that I suppose that let ray x1 has electric field E1 and ray x2 has electric field E2. Now if I plot my electromagnetic radiation, electromagnetic wave, it looks like this. It looks like this. So here we have, this is electric field and this is magnetic field. So this is magnetic field and this is electric field. So it means that our electric and magnetic field, they are of this form. E1 is equal to A1 cos omega t minus k x1. x1 is for the ray x1 and E1 is the electric field of this ray A1 and A1 is the magnitude of ray x1. Similarly, E2 is the electric field of ray x2, so E2 will be A2 cos omega t minus k x2. These are the electric field of ray x1 and x2. So I will stop my video here and I will proceed in the next video.